Alrighty, let's get started. Yeah, so most of you probably already know me. If not, I'm Sam. I've done some work for the XSF in the past, including being an editor and on the council for a while. And I've also written a number of XCPs, including 0393 message styling, which is what we're going to talk about today. It wouldn't be a presentation to a standards body without BCP 14 language, of course. That's a hilarious standards joke. We'll never mention that again. So yeah, let's talk about XCP 0393. So message styling is a simple text syntax for use in instant messages to add simple styles. There's a lot of them you're probably familiar with. It has inline styles such as emphasis, which is normally italicized, strong emphasis, which is bold, strike through, self-explanatory, and pre-formatted text, which is normally just displayed monospace. And it has some block styles, like a pre-formatted text block with a sort of optional and currently unused tag, and block quotations, which can be nested and can be rendered in a number of different ways. So one of the things with message styling that I tried to do from the beginning was make sure that the styles themselves, it's not about formatting. We're not saying this text is bold. We're saying it's strongly emphasized, kind of like HTML or LaTeX, where the formatting might look different or be a bit different on different clients, but the meaning should be the same. It should all convey the same thing. So for example, a block quote might be simply wrapped in quotation marks and second level one's indented, or it might be shown with some kind of indentation level indicator at the beginning, like emails often do. It really doesn't matter if one client does one and one does the other, as long as the intent remains clear. So let's talk about, design considerations. That is the extent of the styles. There are no more. It's a very small, more or less straightforward spec. So how did we design this? Well, it's pretty straightforward. It's basically what WhatsApp does. The only thing to note is it is not Markdown. People say that a lot, but if you actually try to use a Markdown renderer, you won't get the same things. It uses some of the same symbols, but not in the same way and not for the same things sometimes. So you won't actually be able to, if you just throw in a Markdown renderer, you won't get the same stuff. So okay, that's it. We did it. We designed it because we copied WhatsApp. End of story. Any questions? No, of course not. That's not actually what we're talking about today. If you do have any, if you are interested in sort of the design of the spec itself, what I would have done differently, all that good stuff, I have a blog post about it, a sort of retrospective. But what I want to talk to you about today is some of you may know I maintain the Melium project, a collection of libraries in Go for dealing with XMPP and XMPP related things. Libraries, tools, modules, it's kind of a whole suite of things. And fairly recently, the main Melium XMPP library got a styling package, which implements message styling. So it's the API of that I'd like to talk to you about today. So I'm gonna, and don't worry, you won't have to, if you're not a Go person and you don't know the language, it's no big deal. We're really kind of going to be talking about more language agnostic things. So I had some requirements, including that the library is general purpose, so it can't be tied to a specific output markup. We don't want a library that just converts to HTML, for example, or to Android styled spans, or whatever your, whatever that output would be. We want something that allows us to not have any sort of pathological edge cases. We'll come back to that in a bit. The design of message styling sort of implies that you could have infinitely long tokens that you would have to buffer into memory. So we wanted a design that let us work around that while still using the kind of WhatsApp-esque styles that a lot of people already know. Along those same lines, we wanted to not have to parse the entire document. This one is one I don't recommend people writing their own libraries do. It does make things a lot more difficult, and it's normally not necessary. If you're just parsing XMPP messages, chances are the max message length is pretty short relative to the amount of memory someone's going to have available. And it's perfectly fine to parse the entire document and just keep that in memory once or twice and call it a day. But this Go library, I had sort of performance targets I wanted to hit. And since I don't know how people are using it, I wanted to do some optimizations that and not require that the entire document be kept in memory. And finally, this is a requirement that sort of comes from the spec. It recommends that the styling directives, the actual thing, the little asterisks or tildes or whatever that trigger a different style, it recommends that they be displayed alongside the text. So I wanted a way to distinguish those from the text so that you can add formatting to those separately. For example, Conversations does message styling, and it shows those kind of with a lower contrast from surrounding text. So we want the library to be able to do that. Those were the only requirements I had going into this. So the library itself is a pretty simple, straightforward API. This is more or less the extent of it. There are some other things in the package, but as far as decoding and doing the styles go, this is it. We have 3 types, 1 function, and 6 methods. We're not going to talk about all of these, but we will sort of focus on a handful of things. The most important thing being this decoder type. The decoder is what you create to actually parse and handle a document and figure out what the styles are. And you create that with a constructor. We'll skip over that. Doesn't really matter. If you're not familiar with Go, a reader is just anything that lets you read bytes. So that might be it's an interface, kind of like Java or Python, I think, has something similar. It lets you, so it might be a network socket or a file or another reader type wrapping a string or a byte slice. The only reason I mention this at all, this is just a constructor, it's really boring, is this is how we meet that goal of not having to buffer the entire document to parse it. We actually are parsing from a reader, not from a byte slice or a string, for example. There's also the skip block and skip span methods. These are just we're going to ignore these. They don't really matter. They're just a quick way to say, okay, skip over parsing the rest of the current block style or the rest of whatever current span we're in, inline span. That's just a sort of performance thing. If you're writing, I don't even know, if you're writing an editor maybe and you decide you're going to remove something, you don't want to bother parsing the rest of it. We're not going to talk about those. They don't really matter to the API. The really important method here is the token method. So this is how you pop the next token off of the reader. So it scans, looks for any of those styling directives, figures out where to break up the text and where styles are going to change. So let's see a quick example of how that's used. If we have a reader, in this case, it's just a string. Again, if you don't know Go, this is just we're wrapping a string in something that allows us to read from it. So we have a document there. We create a new decoder around that document, and then we'll iterate we'll iterate infinitely in this case, popping tokens from the decoder and then doing some error handling. So that's how you sort of use the basic parsing of a document. This token method, that's the important thing, of course, returns a token. So it's important that we look at what that is. So that's the next thing we're going to kind of focus on. And a token, it really is pretty straightforward. It has a style. So the tokens in this are anytime the style changes, we start a new token. It has the actual data in this token. So for example, if we were starting a pre-formatted text block with those triple backticks, that's what would be in data. We'd get the start pre-formatted block token, and that would be that start triple backticks. And then info is if we are in only for this code fence block, the info string, just as a special case, that little extra bit after them that's optional is stuck there for convenience. There's also an optimization here that I don't love, but I think it is important that we have this copy method. So tokens actually are only valid until the next call to the token method, because this data and info slice will actually be mutated out from under you. And that's not great. It can lead to a lot of bugs. But for performance reasons, since I don't know how people are going to be using this, it's something I wanted to do. So there's a copy method so that if you need to use the token beyond just the immediate, beyond that first call to the token method, you can make a copy of it and continue to use it. That'll have to do some slightly more expensive allocations of new byte slices. It's not great. I really don't like that sort of the safety there, but this is supposed to be a low-level API that can be built upon later, which I'll probably mention in just a little bit. So I'm a little more okay with this sort of unsafe mutating. So tokens all have a style. The style actually is the thing that represents the what styles we have applied. Bold, italic, or strong, emphasis, strike through, all that stuff. And that's a type that's an unsigned 32-bit integer. And the reason for that is it's a bit mask. So we have we also have a handful of constants in the package that represent the different styles. So block pre, strong span. If you're not familiar with this syntax, this is just defining a bit mask. So iota is incremented for every new constant. So the first one is 1 shift left 0. The second block quote will be 1 shift left 1. Each constant in this list will be just a 1 bit further on down the chain. If you're not super familiar with bit masks, also don't worry. We'll talk about how this can be made easier in just a little bit. So one of the ways we meet one of our initial goals is we also define styles for the start and end tokens that trigger actual styles. So this isn't part of the spec per se. These aren't actually styles. But we treat it as the style should represent the style type should represent the exactly what a value should look like, including things that aren't sort of officially part of the spec, like the start tokens, which might look differently. So this helps us meet that goal of being able to distinguish the styling directives from the actual styles. So here we can see there's some block quote and end start or styles. Same for the spans. So we have our span pre-start, span pre-end, so that we can tell where things are starting and ending. There's also a handful of sort of special constants that are no longer part of the bit mask, that are just predefined combinations of the other constants. So things like block that includes the pre and quote blocks. That way we can easily check, is this token in a block? Is it in a span? So an example of using this, the directive bit mask has all of the various start and end sequences in it. So by using some simple bitwise math, we can check if a token is a styling directive versus just text that is styled. This makes things pretty easy. If you're not used to bitwise math, this probably isn't the most readable thing in the world. But it does make it really easy to do things like, for instance, if we wanted to write a converter that outputs HTML, we can have a big switch statement, or in other languages, this would probably be an if-else block, where we check for individual styles, and then we write output based on those. So in this case, we're checking for if we've hit the span strong start token, output that start element with some formatting. We use code in this place, and the start strong tag. And then later when we hit end, we will also add that closing token, and then finally close the strong. And then somewhere in here, there would be a default or final else where we said, and for anything else, just spit that text out because it's plain text and we want to display it. So it makes it really easy to have a kind of big state machine where we can convert to some other format. But like I said, it's not the most readable thing in the world. So because style is a separate type and we're not using a literal uint or unsigned integer type, we could also add methods later to kind of simplify some of this. I haven't decided about this. I would love to get feedback from people on this. They do kind of clutter up the documentation, and you have a lot of methods to do something relatively simple, but it makes the code using this a lot easier to read if we can just say, token.style.isEmphasis or something along those lines. So this is a possible enhancement for the future for readability that I would be curious to get people's opinions on afterwards. So we're kind of into the open questions with the library section now. If we go back to our initial API, you'll notice there's also this quote method. So the style currently only tells you that you are or are not in a block quote. It doesn't tell you how many times that quote has been nested. And that's what this method does. If we're in the sort of second level of a block quote, this will return 2. there's also this style method, which returned the most recently, the style of the decoder at the current point in the byte stream. This is a little weird because if you remember, it's duplicated on the token struct. There is also a style on the token. And since we've just gotten the token, like that's already got the style, why do we need a method? And I haven't quite, this was sort of an oversight initially. I don't know where this belongs. So I'm tempted to say token needs to completely say exactly how this token is formatted, which means style should live there and this method should go away. It also means quote would be moved onto token. So style is duplicated, quote is over on the decoder. It should probably be moved into the token. But there's also the question of whether the quotation level is a property of the token or a property of the style. So maybe we could also have that be another handful of bits in the bit mask. So for instance, the upper 16 bits could be an integer that defines the quotation level, and then the lower 16 bits could be the mask that tells you all the various actual styles, which means even more bit math you have to do. And I don't know that I love that, but again, that could be solved with some of those convenience methods. So for now, all the data's there. I don't really want to touch it. But technically, we haven't hit 1.0. Not many people are using it yet. These are some things I have thought about cleaning up that may be worth the time later. And finally, iterating. I think I thought about this wrong the first time. So you'll notice back to this earlier example, after we've popped a token, there's a bunch of error handling we have to do, and it's kind of weird and verbose, and I don't love that. I was thinking about this sort of like an XML or JSON decoder, but it really isn't. There's not that much stuff we're doing. We're always just going to be getting a style. We're not going to be encoding some other existing thing into a message styling. It's not a data language. So I don't think that was the right abstraction. I really should have thought of this in terms of an iterator that just iterates over a stream of tokens, in which case I could have done something like this, where we have a next method on the decoder, which is the thing that actually pops the token, stores it internally. If any errors occurred, the error would be part of the decoder state. And then the next would just return true or false. Do we want to continue the loop or break out of it? This makes things a lot cleaner. We can always check the error state after we've broken out of the loop. We don't have to do any weird early checks to see if we've reached the end of the file and break out. Next handles all of that for us. So this is something I would really like to do. I'm just nervous there's something else I'm not thinking of, that thinking of it in terms of a simple iterator wouldn't work with. But I'm reasonably sure I would like to move to this much, much simpler method of error handling and iterating. And that's really it. That's my entire description of how I think we met all of the goals from the initial design considerations. I think we came up with a decent API that, while I use my projects in Go, I think this sort of API would work really well for any project. One of the nice things about doing the token stream this way is that it doesn't lock us into only doing the token stream. We could also have a higher level abstract syntax tree or something else built from the token stream later, which is where we would get rid of some of those optimizations that I said were issues, like being required to copy tokens. If we're building an AST, we can build that, and that is the copy. And now we don't have to worry about things being mutated out from under us. And we have a higher level abstraction that's easier to work with. So the nice thing about doing it this way is it doesn't prevent us from doing other things like that in the future. So yeah, if you are interested in Go at all, join us. We have the Go chat room, which was recently moved to a nicer domain. If you're interested in Melium, there's also a chat room for that. And that's me. That's all I've got. Hopefully you learned something. And any questions? So let's see. We've got one in the chat. Question is, would it be possible to reuse the decoder API with a different styling specification? Such as XEP0394. I don't see why not. I don't think this API would prevent any sort of other, adding on something else later. In fact, I'd actually say it helps because, yeah, it's like I mentioned at the end, one of the nice things about doing this is because it's not, we're not sort of stuck on a single, we're decoding tokens. That doesn't mean we can't say, okay, now that we have this token, do something else, like figure out exactly where in the output stream we were and add some tags to the XML based on that. And the token actually makes that easier in some ways than, say, an AST, where if we had the whole tree already parsed out, we might not have kept all that info about offsets in the original document. Whereas the token reader allows us to do that. In fact, I didn't show it in here, but there's also a separate, there is a method in the package that's the sort of just the splitter that's meant for splitting tokens. It doesn't figure out if they actually start a style or not. It doesn't figure out any styling information itself. It's just a naive, excuse me, just a naive split function that says, okay, this looks like it might be a token. Split it out. Here's the byte slice, which can be used to, if there's some other logic or extension you want to build, you can sort of build your own decoder on top of that. It's sort of the low-level primitive that the decoder is built on. And it just occurred to me as well. I said I was going to talk about this and then didn't. But sorry, I'm losing my train of thought today. Oh, it'll come back to me. Sorry. Anyway, any other questions? I had something and it left me. But yeah, thanks. I do think this API works really well for being able to extend it later or build other things on top of it. Go back to my somewhere early on in the requirements. There was a skip ahead a bit. Sorry. Oh, the pathological edge cases. So a thing I didn't mention in here that sort of to your point or to the previous question too is one. So one of the edge cases with this is if you want to say here's a styled span, all of the there's the edge case where someone could just make the entire message one style, and if that message is very long, that's one token. Which isn't great, right? That means you go back to the issue of having to kind of buffer a very large amount of text. But one of the other nice things about this API is it doesn't tell you or make any guarantees about where tokens are going to be broken. So if we have 10 paragraphs of text that are all bold or emphasized, we could quite easily kind of split that up into multiple tokens. And it doesn't matter if one implementation of the decoder splits it in one place and one does another, or we add limits and say, okay, only tokens can be no more than, I don't know, some reasonable limit. 1 kilobyte. That's probably pretty big actually, but we could do something like that, split them up, and as long as you're just iterating over tokens and taking the style that's on them and putting it back together into whatever formatted document you have, it'll still look exactly the same. Which anyway, that's just a sort of optimization this allows us to do, where the original sort of borrowed from WhatsApp styling doesn't really lend itself to tokenization. But by doing it this way, we can split up large tokens arbitrarily and not affect the final output, which also is very nice if you're building an AST or something later. We don't have to process everything all at once. So anyway, I was really happy with how it turned out. It is a little bit low level in some cases, but I think it lets people build really nice abstractions on top of it. So anyway, that slight detour. Any other questions? Well, I guess if there's nothing else, that's all I have. If anybody has anything else they want to talk about, I can leave the room open. Again, next week, different date and time, but the jmp.chat, one of the employees is going to be talking about that project. So if you're not familiar, that's using sending regular text messages and contacting telephone numbers through XMPP, and it's a really cool project. So definitely worth tuning in for that. I think that's also our last actual sign up. So please sign up to do a demo or something so that this whole experiment doesn't die before it's barely gotten started. All I've got. Thanks for coming, everybody. See chat. Yeah, thanks everybody. Oh, also, if anybody has any sort of roundtable discussions they'd like to do, I also think if you're not, not comfortable hosting a talk or doing a talk yourself, put some discussions that might be interesting on the calendar. I think it'd be really fun just to, I don't know, sit around and argue about how message archiving should work or something. Idea share sort of things.